Okay, let's look at a little bit more of a complicated equation. Now, with this one, we've got a rational equation. We see these variables down here in the denominator. Okay, anything with rational equations, or expressions, simplifying rational expressions like adding, subtracting, multiplying, dividing, even solving rational equations is going to be way easier if we have the factored form of any binomial or trinomial that we see. So when we see 9x plus 9 here, okay, we want to factor that out into the two parts, two factors of that denominator. Okay, so now we're here. When you look at these denominators and what the method that we've been talking about for simplifying these and for solving these is, if you don't want any fractions, multiply by the greatest common multiple. Okay, and the least common multiple, not the greatest, the least common multiple of all of the denominators together. So what is a product that I know of that each one of these denominators fits into, for lack of a better word? And just to give you an idea, when you're doing this, there is a method that will always work, but it gets a little complex. Let's just take a look at something very simple for a second, just so we understand the concept here. If I had just a basic rational linear equation. In fact, we could mess with this a little bit more, but the lowest common multiple of these numbers sometimes is the biggest number here. Check that just to make sure, right? See, like 12 is a multiple of 3 and a multiple of 4. So 12 is the least common multiple, right? Now that is the product of 3 and 4. Now when you look at this, you look at these two denominators, okay? These two denominators, if you multiply them together, would look like this, right? So the least common multiple here is this denominator. So that is the value that I'm going to multiply everything here by. I'm going to multiply by 9x plus 1. I'm going to try to color code this so it doesn't get too crazy. The first thing I'm going to do is take this entire number and multiply it times this. And when I multiply what I see here by what I see here, and this is over 1, and I cross cancel, all of this is going to cancel. Everything that's down here is going to cancel with everything that's up here. And I'm going to be left with an 8 on the top and a 1 on the bottom, right? Then when I go and I take this and I multiply this times this term, the x plus 1 that's down here on the bottom will cross cancel with the x plus 1 that's over here. But that still leaves the 9 over 1 to be multiplied times this 8. So what I'm going to end up with there is 9 times 8 over 1. And then when I multiply this times this third term over here, this 9, right? This 9 is going to cancel with this 9, which is going to leave the x plus 1 on the top. We're going to leave that in parentheses, remember, so that when we multiply it times the 4, we know to distribute that. Okay, so this entire equation becomes 8 equals 72 minus, and you can rewrite this if you want. Okay, now when we're doing this, let's take this one to the end, because there is one of these how should we say, pitfalls that we often see when we're solving these equations. So this is the situation we're at right now. So we have 8 equals 72. I'm going to distribute this 4 into the parentheses. So we have minus. Now I'm subtracting this product, right? So whatever I get from this product, that's 4x plus 4, right? But I am subtracting this, which means I'm subtracting every term in this product. So be aware that because I'm subtracting this, whatever this, sorry for the ambiguous term, but whatever this becomes, I have to subtract that. So really that becomes me subtracting the 4x and subtracting the 4, right? We essentially distribute this to these two terms. We have 8 equals 72 minus 4, which is 68, minus 4x, and then you could take it from there.